All right, hi guys. I might have to break this video into a few different parts because I think it'll probably take a while. Anyway, we'll see how we go. So it should be today. This lesson should be planned for Saturday. I think we're up to, and we're moving on to sketching quadratics. Now, sketching quadratics. Sorry, I'm getting notifications on my computer. Sketching quadratics is really important, and it's one of those skills. It's got a lot more like of the hardcore math skills that we've been doing this year compared to plotting quadratics, which is quite a soft skill. So with sketching, we're doing a lot of the things that we've been practicing all year round. And it's one of those things that if you get it right and you get the visualization in your head, it's going to help you for years and years to come for solving maths and thinking about the kind of problems and the kind of solutions that you have. Okay, so what we're interested in sketching quadratics is three features, and that's going to help us sketch. So the first one is x-intercepts. Now to find that, you're going to be using factorization or quadratic formula, whichever you prefer. Okay, whichever one works for you. You're going to be using, you're going to be finding the turning point. So remembering from where we were talking about the other day, that's that point where the quadratic turns around and goes back in the other direction. And for that, there's two different methods that we can use for that as well. I think there's going to be one that's going to be easier, but there's one that's a really, it's a good skill to practice. Okay, and the last one's the y-intercept, and that's, familiarly from where we were doing linear graphs and stuff like that, that's where x is equal to 0. Okay, a couple of things to keep in mind while you're sketching. So as well as those things that you've got to do, these are some things to think about. So is your quadratic a smiley diley or a frowny downy? Now, smiley diley is looking like that. It's a happy face. Okay, frowny downy, upside down, sad face. Okay, so two different forms of quadratics, and we'll look at that a little bit. Second thing, it is possible that you will have no x-intercepts, one x-intercept, or two x-intercepts. So keeping that in mind, you're not always going to have x-intercepts to find. Okay, and we looked at that a little bit when we were doing factorizing and quadratic formula and looking at some cases where you don't have x-intercepts. Number 3, it is not possible that you will have no y-intercepts unless your domain is restricted. So unless you're told that, say, you're looking at the function x squared, okay, where x is greater than 1, okay, because you're only looking at the values where x is greater than 1, that's not including where x is 0, so therefore you would not have a y-intercept. But for every other quadratic function, okay, unless you're looking at a specific domain, you will always have a y-intercept. So that's quite important to note as well. Okay, so we're going to go straight into it, and we're going to sketch the following quadratic function, which is f of x equals x squared minus 4x. Okay, so for this one, f of x equals x squared minus 4x, the first thing we're going to do is have a go at finding the x-intercepts. Okay, so I always like to write it down, x-intercepts, comma, f of x is equal to 0, okay, because that's what you're solving for. You're solving for where y is 0, where f of x is 0. Okay, so we let that equal to 0. Okay, and we've got x squared minus 4x. Oh, I have no idea why I wrote the 0 on the left-hand side. I'm just going to flip this around. So x squared minus 4x equals to 0. Okay, now remembering some of our techniques from factorizing that we were looking at the start of the year. The first one being, are there any common factors? The second one being, do you have two numbers that add to make the middle term and multiply to make your end term? Remembering on this one, there's no end term on this, so that's obviously probably not going to be one, but you could add in a plus 0 if you wanted to at the end. And the last one then being, if you don't have either of those things, then you're going to look at using quadratic formula instead. Okay, so from here, we do actually have a common factor of x squared and 4x, so we can take out x as our factor, and then we're left with x minus 4, okay, and that's equal to 0. From here, now we can say that we know that either x is equal to 0 or x minus 4 is equal to 0. Okay, and we add that 4 onto the other side, cancel it out, so therefore x is equal to 4. Okay, so there are our two intercepts, and I'm going to mark them on the graph. So we've got an intercept at 0, okay, and we've got an intercept at 4. Now, it should be pretty obvious that that x-intercept there, that's also going to be the same as your y-intercept because it's going through both the x-axis and the y-axis. But if you wanted to then find your y-intercept as well, just to confirm, okay, y-intercept x equals 0, So now you're finding f of 0, okay, which is 0 squared minus 4 times 0, okay, which is 0 minus 0, which is 0. Okay, so that confirms that that's at the same point there. All right, lovely. Next thing we're going to do is find the turning point. Now, finding the turning point, like I said, there's two methods to doing it. The first one, which I think you guys are going to find a lot easier, is looking at the midpoint of your two intercepts. Okay, so remember that you've got this kind of axis of symmetry which goes through any quadratic at the turning point. Okay, so you've got that symmetrical point, and because both of your intercepts are at 0, okay, that axis of symmetry should be halfway between the 2 points that are equal. Okay, so because those two are equal, then you should be able to find the turning point from there. Okay, so in this case, now to find the turning point, okay, you can say for your x coordinate, okay, that's going to be 0 plus 4 divided by 2, okay, which is 4 divided by 2, which is 2. Okay, so you add the two coordinates together and halve it. That's how we always find the midpoint. Okay, and that gives us 2, so we know our x coordinate is at 2. Now to find the y coordinate, we're going to sub in 2 into the equation. So we're going to use f of 2. So that's 2 squared minus 4 times 2, okay, which is 4 minus 8, which is negative 4. Okay, so our turning point is at 2, negative 4. Okay, and then from there it's just a matter of joining up your points. Ooh, I did not draw. There we go. Hopefully yours looks a little bit better than mine. You should have a bit more, it should be a bit more curved at the bottom, not quite as pointy as that. Probably a little bit more symmetrical, but that's why we call it sketching. Okay, it doesn't have to be perfect. Alrighty, what I'm going to do is I'm just going to rub this out. I'm going to give you guys an example that I would like you to try yourselves of a similar one, and then I might stop this video and we might go on to a slightly more difficult example after that. Okay, so just give me 1 second. I'm just going to erase this. Okay, cool. So here's another method of, here's another question for sketching. So I'd like you to have a go at that one. Try and do it yourself and then listen to the answer. Okay, so I'm going to go through the answer now, but I would like you to try it yourself, so please pause it and then have a go. Okay, so for this one, I'm just going to change my pen color. Let's go for blue. Alrighty, so we've got negative x squared plus 6x. Now this negative x squared, that's going to change what our function looks like, but we'll talk about that in a second. Okay, so first thing again, we're going to find the x-intercepts. Okay, so x-intercepts, f of x is equal to 0, so we've got negative x squared plus 6x is equal to 0. Okay, now from here, I'm going to take out a common factor, so I'm going to take out x. Now in here, I'm going to be left with negative x plus 6, okay, equals to 0. Now you could have taken out negative x as a factor, and that would have changed that inside sign to being a negative, okay, but I just want to keep it consistent for the moment, so I've put that as negative x plus 6. Right, now when we're going to use our null factor law to solve, okay, x is equal to 0, or negative x plus 6 is equal to 0, okay, so that means that negative x is equal to negative 6, which means that x is equal to positive 6. Okay, so we've got x is 0, again that's going to go through the middle, and we've got x is 6. Right, now I'm not going to bother finding the y-intercept for this because obviously that's going to go through the middle again. Okay, you probably should for good practice, but we know that's going to be true. Now, turning point. Okay, with the turning point, again we're going to find the x-coordinate first. So we're going to look at x, which is 0 plus 6 divided by 2. Okay, so that gives us 6 over 2, which is 3. Now f of 3, okay, is equal to negative 3 squared plus 6 times 3, okay, which is negative 9 plus 18, okay, which is positive 9. So our turning point is at 9, 3. Now you'll notice in this case the turning point is above the two intercepts, whereas in the last one the turning point was below. So that's going to indicate to us that we've got an upside down quadratic, a frowny downy, as opposed to a happy face one. All right, so our quadratic is going to look a little bit like that. Again, yours should hopefully be better than mine, but there we go. Okay, so last little bit I want to do in this video is just to show you how another way you can find the, what am I talking about? The other way that you can find the turning point, okay, which is using completing the square. So if we know that f of x is equal to negative x squared plus 6x. Okay, now remembering that when we're completing the square, first thing we need to do is take out this negative, because we only really want to work with a positive x squared. So we're going to change this to negative x squared minus 6x. Okay, and that works quite well from there. Oh, okay, and then from here, then remembering when we're completing the square, we've got these brackets and we want to hang the whole thing squared. So we start off with the x, and then we've got whatever, we're taking half of that middle term, okay, which is 3. So half of that middle term, and then we're squaring the whole thing. And remembering that because we're now adding in like a 3 squared, we also have to take away 3 squared on the end. And now I'm going to put this in brackets because this is all, we've got a negative around all of that because we took the negative out from that whole thing, so we still have the negative from the whole thing there. So I'm running out of room, so I'm just going to move over here. So from there, okay, we can then say that's going to be negative x minus 3 all squared. Okay, 3 squared is 9, and because now we've taken away those big brackets, so we're going to put that negative back in again. So now we're going to end up with plus 9 from the 3 squared. Okay, and what we can see is that completing the square, that you've got that there, that gives us the coordinates of our turning point. Remember that whenever, like when we're factorizing, you always end up with the opposite sign of what's in your brackets. So now we can say the coordinates of our turning point are 3, positive 3, and positive 9. Okay, that's our turning point. Okay, and we can see that there. So that's how completing the square works as a strategy to find the turning point. All right. What I might get you guys to do is a couple of questions. I'll attach them to the document. So have a go at those now, and then we might move on to some harder sketching in a minute. Okay, well done.